Good morning, good afternoon, or good afternoon. Welcome to the webinar. This is Exploring a Career in the Minerals Industry. This webinar is hosted by the Geological Society of America, the American Geosciences Institute, and the American Geophysical Union, and the Society of Economic Geologists. Thank you for being with us today. My name is Talia Bear. I am GSA's Diversity and Career Officer, and I will be moderating today's webinar. You will have two presenters today. One will be Terry Briggs, who is part of the South American Regional Leadership Team at Newmont Goldcorp, and Elaine Lord, who is an intern at Newmont Goldcorp and a graduate student at the University of Alberta. Before we get started, I'd like to go over a few things with you so you know how to participate in today's event. Everyone has joined the webinar on mute. In the top right-hand corner of your screen, you'll see a control panel. You'll use this control panel to ask questions during the webinar and type them into the questions box. Because we have two presenters today, please direct your questions to a specific presenter if you can. And we'll have some time at the end to address these questions during the Q&A period. The webinar will be 1 hour in length and is being recorded for on-demand viewing. An email with the recording will be sent to you in 2 days. At the end of the webinar, we will have a short survey. Please take a moment to fill this out. Your input is very important for the organizations hosting this event and for our presenter, and really helps us tailor future webinars. So with that, why don't we begin the webinar? Our first presenter will be Terry Briggs from Newmont Goldcorp.
All right, thank you for the introduction. Hello, everyone, and welcome to this webinar focused on geoscience careers in the minerals sector. It's a real pleasure to give you an overview today from the perspective of myself with over 20 years industry experience, and later in the presentation, Elaine will give an overview as a recent intern in the sector. I'd like to thank up front the Geological Society of America, as well as other supporting partners already mentioned, like the Society of Economic Geologists and American Geosciences Institute, in making this series of webinars on career opportunities for graduates available. In this case, it'll be focused on the hard rock mining sector. This provides many of the minerals used in our everyday life. Whilst this is a general overview of the sector, the presenters would also like to thank Newmont Goldcorp, the world's leading gold company and producer of copper, silver, zinc, and lead. The company's world-class portfolio of assets and prospects and talent is anchored in jurisdictions such as North and South America, Australia, and Africa. Newmont Goldcorp was founded in 1921, and its values are focused on safety, integrity, sustainability, responsibility, and inclusion. As an introduction of who I am, I was fortunate to do geology as a subject in my final year of high school. I was hooked when we spent a week mapping in the remote part of Australia called the Flinders Ranges. I subsequently undertook a geoscience degree focused on economic geology at Monash University. I was lucky enough to undertake an internship of my own at what was then the largest vertically integrated zinc company. And I subsequently worked through a graduate program for the next 3 years, which saw me work in regional exploration for sediment-hosted base metal, precious metal deposits in Western New South Wales, as a project geologist at what was then the second largest lead zinc operation in the world, Century, during its construction and commissioning, followed by a stint undertaking near mine exploration at an underground polymetallic volcanic-hosted massive sulfide deposit in Western Tasmania. Then, a downturn hit the zinc industry, and I ultimately moved on to another base metal miner, working as a production geologist at 2 different MVT Irish-style lead zinc mines before another downturn struck and the mine was closed, which left me working on a reopening study, which it didn't do for a few years. So I went and worked as a senior mine geologist at a series of open pit and underground mines in the Kalgoorlie district of Western Australia. After a stint here, I went on to work as a technical services manager at an underground copper gold mine in Eastern Europe, and as a resource superintendent at an open pit copper gold mine in Southeast Asia. And just over 10 years ago, I joined Newmont Goldcorp's Technical Services Geology Department providing support to our global projects and operations. And in the past few years, following completion of a Master's in Engineering, I've worked in our corporate development group, and I'm currently focused on regional integration activities in South America. So enough about me. What exactly is this webinar going to be about? The aim is to give you an overview of just what the minerals industry is, which is, in short, comprised of the exploration and production of commodities such as copper, zinc, nickel, gold, silver, as well as rare earths that are becoming more important with the growth of the electric car industry, for example. As you'll find out, geologists play an integral role in this sector of the economy, undertaking everything from the discovery and definition of potentially economic deposits through to their exploitation and subsequent rehabilitation. We also hope to provide you with some helpful tips on how to potentially work in the minerals industry if that is a career choice that is of interest to you. So let's start with why is the minerals sector important? It provides the vital minerals that are used in many parts of our daily lives as demonstrated in this chart here. In the US alone, for example, an average person uses 12 pounds of copper per year. Copper is found widely in electrical equipment, cars, building, construction, and industrial machinery. Mining of minerals is certainly not a new industry. It has a long history dating back as far as 6000 BC, where gold was fashioned for jewelry. In 4200 BC, the use of copper in antiquity was of significance in amongst the first use in tools, implements, and weapons, followed by mining of silver in 4000 BC, lead in 3500 BC, and tin in 1750 BC. While we're on statistics, this is one of my favorites. All the gold that has ever been mined, which recently was 155,000 metric tons, would fit in 2 Olympic swimming pools. So if you want to challenge yourself, you can look at the density and volume of that, but that's all the gold ever mined. So is the minerals industry still important in America? I think is another good question. And coming up, we'll explain where mineral mining is undertaken in the United States. But as of last year, the estimated value of this sector was $82.2 billion. That doesn't include other natural resources such as petroleum and the like, oil and gas. The mining industry in 2015 employed over 158,000 people directly in the United States as well. But when you head to countries such as Australia, Canada, South Africa, and Chile, it's an even larger portion of their economies, and by inference, employs a larger number of geologists in their mineral sectors. If you want to look at where geologists can work in the mineral sector, this graph gives a good overview of what's called the mineral resources development cycle. This starts with identification of prospective geological terrains. This could include areas such as the copper-rich Andes from Chile to Colombia, the gold-rich Witwatersrand in South Africa, or the Carlin Trend in Nevada, or the base metals-endowed Tethyan mineral belt running through Eastern Europe and Eurasia. When you know what you want to be, this narrows down to a regional scale with a selection of exploration tenements. This is ground that a company can explore for deposits on, which is followed in an activity form by a series of exploration work to test geological concepts to find a potential ore deposit. This usually starts with review and consolidation of remote data sets, such as aeromagnetics or district-scale geological maps. These are often available from government bodies such as the United States Geological Survey or Geoscience Australia. Testing of anomalies is followed up in the field by non-invasive work such as ground magnetics, grid soil sampling, ground mapping, and other methods to test targets before drilling is undertaken. The odds of a discovery turning into an economically viable deposit is surprisingly low. It's reported to be 1 in 1,000 of the approximate 10,000 properties being explored today will make it all the way through to an operation. Once a discovery is made, it can then take 10 years to go through the definition and permitting phases prior to construction. Adding more pressure to this is that discovery rates are declining globally. By example, there are currently 16 aging copper mines accounting for 41% of current production, which highlights the importance of this cycle continuing and exploration continuing to have discoveries. A typical operation can last for many decades, requiring ongoing geological support in continuing to define a deposit, as well as ore control in the support of extraction and reconciliation of material. Closing out this cycle is the reclamation and closure requirements. This is an increasingly stringent activity compared to historical practices and is a particular field of employment for environmental specialists. And thereon, the cycle continues, hopefully leading to more discoveries to feed our insatiable appetite for metals. I talked earlier about the importance of the mineral sector in the United States, as well as other countries. The map shown here on the right displays a strong predominance of minerals in the western United States, such as the Northern Cordilleran Volcanic Province, which extends through British Columbia into Canada and onto Alaska. This is important for gold and base metal mineralization, such as the Kensington, Pogo, and Fort Knox deposits, which are in production today. And if you head up to the remote northwest of Alaska, the world's largest zinc mine, Red Dog, is currently being operated by Teck. In the lower 48, Arizona, you can see a large cluster there of mines, is home to the world-class copper deposits that are being mined by Freeport-McMoRan, one of the largest copper companies in the world, with operations in South America and Indonesia. In northern Nevada, the world-class mines, such as those being mined by the newly formed Nevada Gold Mines, a joint venture between Barrick and Newmont Gold Corporation, has been in production in its modern form since the early 1980s, but dates back as far as 1874, when gold was first discovered. In Utah, the large Bingham Canyon copper mine is being operated by Rio Tinto Kennecott, and at one point provided 25% of the country's supply of copper. There's also zinc mines in Tennessee and polymetallic deposits in Minnesota. In terms of global production, the United States still accounts for top 3 production in a series of commodities, including gold and lead, and attracts 8% of the entire global minerals exploration budget as of last year. When you're looking at what kind of roles does the mineral industry employ geoscientists across this resource cycle, I've highlighted 4 main disciplines of work in the sector that I'll mostly talk to, as well as a couple of important specialist supporting roles. One of the most exciting parts of work a geologist can do is that of the exploration geologist. They undertake work duties such as target identification, developing and undertaking programs to test these from sampling to drilling and interpretation of the results. They're often supported by specialists such as geophysicists, who deal with interpreting the geophysical properties of deposits, such as gravity, where sulfide-bearing deposits are typically denser than the surrounding country rocks. They may be conductive and respond to electromagnetics. They may even be magnetic. Geochemists, they determine and analyze the best method to test everything from soils, stream sediments, rock chips, and drill core for target elements using different analytical techniques, as well as potentially the identification of trace elements that could lead to be a pathfinder to economic mineralization. And there's a good example in the top pictures there of some of the remote work that can be undertaken, such as mapping and sampling in Canada, or drilling being undertaken in Suriname in Northeast and South America. In the production environment, the mine geologist is king. They ensure only the best quality material is processed, and they could either work in an open pit environment, like the bottom left image, or an underground environment, such as the bottom right image, where we have a couple of female geologists doing ore control and sampling in these images. Someone who consolidates all of this information for advanced projects or operations is the resource modeler. They determine the volume of economic material. They work with advanced 3D modeling software to create an accurate estimate of the tons, grade, and contained metal that is used by engineers to determine the best mining method. And these results are also provided to shareholders and relevant stock exchange because they form an important metric by which resource companies are valued, and that's the amount of contained metal that they have in reserves and resources. So having gone through all of that, what is a typical activity a geologist undertakes in the minerals industry? A good portion of a geologist's time, especially early in their career, is focused on field work, collecting data that could include geological mapping of outcrop, overseeing sampling programs, or remote data gathering and coordination and management of drilling programs. All of this, of course, is then followed by integrating all these different data sets. There's a great example on the left here, which shows all the different types of data sets, which could be geological, geophysical, geochemical, geomorphological, and interpreting this information to determine not only where mineralization could be, but how it might behave spatially. Today, a lot of this work is done in 2D through GIS programs or in 3D, as previously mentioned. Even virtual reality is in use these days, which provides a great and important way to visualize spatially how a deposit behaves in relation to proposed infrastructure, how mineralization may plunge and dip, how faulting could impact the deposit. There's even a great tool we use to show investors an experience they might not show, where you can spatially put them inside a deposit and show all the infrastructure and equipment around them. Moving on from what a geologist does to how, what does the industry look for in the mineral sector? The list here covers items such as what skills, knowledge, and experience are expected. A common question I continue to get asked is, what's the minimum education requirements? Well, this is a 4-year undergraduate geoscience degree. A master's in science is often optional, but it will certainly be required for more senior roles later in your career. A PhD is sometimes beneficial, but it's often restricted to the domain of specialists, such as geochemists, geophysicists, or structural geologists. This is a bit of a differentiator, I think, to some other geoscience sectors. I cannot recommend strongly enough that if you get the chance to do an industry internship, jump at it. Nothing better prepares you for a future career than experience it firsthand. It also helps you know if it's the right career for you. And this is something that Elaine's going to talk about shortly. Likewise, any chance you get to use and experience the tools that industry uses, such as GIS, is going to be beneficial. It's a nice to have though, as most companies do not expect proficiency in this and often provide in-house training opportunities. As for personal attributes, safety is a high priority in the industry, as well as the ability to work in teams, present results in written and verbal forms, and analyze and interpret data sets. In closing on this section, the minerals industry is often located in remote locations. Exploration camps and mines can be located anywhere from the Andes to the Amazon. It is one of the most amazing aspects of this industry in that it's global, and when you have the experience, there's the opportunity to live and work and exposure to other cultures. I was once told by a mentor earlier in my career, the best geologists are those that have seen the most rocks. So taking on those prerequisites, how do you get started in the industry? Some guidance is to look at the subjects you choose as an undergraduate. Field mapping, in my opinion, is critical in gaining skills such as making measurements of structures and stratigraphy. And even if you don't end up undertaking mapping yourself in your career, there's a good chance that you'll be interpreting the products of that work from someone else. As for core subjects, those like sedimentology, mineralogy, igneous petrology, structural geology, they may be the only time you learn the basics, because once you're in industry, it's expected that you understand the fundamentals of being a geoscientist. Economic geology, if it's available to you, is a great course as it covers in more detail the different deposit styles such as copper-gold porphyries, zinc-lead sedimentary exhalatives, magmatic nickel sulfides, or gold-silver epithermal deposits. The geological knowledge of these and their associated formation models are what drive exploration and an operation's success. Then, of course, any experience you can demonstrate developing the non-technical skills listed as critical to your success working in the mineral sector. It may also come as a surprise, but mathematical and computing skills are increasingly important requirements for the roles in the sector to assist in analyzing ever more complicated and detailed data sets. That's not to say this is required for all roles, however. In addition to some of this information, some other ways you can help build up your resume are the following. Some states may require certification as a professional geologist. Having what's called MSHOR certification to work in metalliferous mines, that's the Mine Safety and Health Administration, is required to work if you're on site more than 5 consecutive days or 5 days in a year in the United States. Most employees, however, would provide this certification, but it gives you a good understanding of some of the safety requirements working in the mining field. First aid training is also a good attribute. I also believe demonstration of participation in industry student bodies can be a great way to get extra experience, knowledge, and networks, and I've listed some of those, and some of them are sponsors of this talk. As previously mentioned, an internship, if possible, is always beneficial. So when you're looking to apply, I've listed a few sources of where jobs are advertised in the minerals sector. The most common for internships and graduate programs are company websites. Some of the mineral companies operating in the US, for example, include Newmont Goldcorp, Nevada Gold Mines, Rio Tinto Kennecott, BHP, Oceana Gold, Kinross, Core Mining, Freeport-McMoran, Hecla Mining, and Eagle Mining as some examples. Note that there's a big difference between major mining companies, such as Newmont Goldcorp, which may have multiple operations, large technical and exploration departments with internal consultants, and junior companies which may have just one asset and limited resources. But with those, as the other benefit is you might get exposure to a broader range of responsibilities. This is really important in my view. Typically, the timeline to apply for these sort of roles is by October for the following summer for graduate and internships. I can't emphasize enough, if you're looking for work in the sector, don't wait until you graduate to apply for roles, because most of them might have closed, and limiting the opportunity to work as a graduate. Contracting is another method to gain experience, as a lot of companies may have field seasons and require geologists to assist with their programs on short-term assignments. And there's also the consulting sector. This is usually reserved for those that have built up considerable experience and can act as subject matter experts or provide support to a company for a project or independent review. Firms such as SRK, Golders, and AMEC provide these services. Now, here's one question you may be wanting to ask. What is a typical starting salary? According to online sources, this is potentially $45,000 to $55,000 per annum, and there's room for this to grow to 6 figures as you go through to more senior roles, which I'll explain shortly. So in closing my section, what does a typical geologist career look like? Similar to many industries, a technical professional such as a geologist will start their work in a graduate role. Other entry methods include coming in as a core logger or a grade control spotter or sampler. These might limit your upward mobility, however. The time frame shown here on the right-hand side can vary wildly, but a typical progression is from a geologist through to a project role with greater responsibility to run programs and budgets, and onto senior geologists, which would manage teams of technicians and geologists, and often drill programs or other district region scale programs. Once you move on to a superintendent and manager roles with more executive exposure and oversight of larger programs or budgets, financial skill sets are an advantage at this level. There is also the option to work for extended periods or even an entire career as a project geologist, for example. And at this level, you could easily keep yourself occupied throughout your career, getting exposure to different deposits, different companies, different operations, different jurisdictions. There's no shortage of challenges or deposits to keep you entertained. An alternative career track may be to become a subject matter expert at this level, and you could become a database geoscientist, a structural geologist, or others. So you don't have to follow the career path as laid out here. The pyramid I'm showing is of my career prior to joining Newmont Goldcorp, and it shows the path I took to go from a graduate geologist through to a project geologist, senior geologist, and up to manager, as explained in the opening of this webinar. The mineral sector for me has been a wonderful journey. You get to work with some amazing people, you get to participate in teams that can achieve great things. It's a sector that is also closely tied to research and development, meaning the skills you learn at university continue to be applied throughout your career. As a global industry, it can allow you to see and work on deposits globally as you build up your experience and skill set. It can also allow you to be based anywhere from capital cities to regional centres. So with that, I'm going to hand it over to Elaine to give an recent intern's perspective, and I look forward to your questions, and thank you for your participation.
Thank you so much, Terry. Just want to put a reminder out there to type in your questions that we'll take at the end of the webinar into the questions box. Okay, so right now we will hear from Elaine Lord, who has been an intern at Newmont.
Hello, everyone. Thank you, Terry and Talia. My name is Elaine Lord. I am a graduate student at the University of Alberta, and I just finished an internship over the summer with Newmont Goldcorp, where I was working with the resource modeling team, coding in Python, and also working with Leapfrog and Vulkan. So some expectations that I had coming into the internship were exposure, mentorship, and networking opportunities. But I was surprised by the robust safety culture that I entered, especially in Newmont Goldcorp, but in the industry in general. Safety is key to operations. Another thing is an emphasis on on-site work experience. So if you have the chance to intern on-site, I would highly recommend it. It looks great on a resume or CV. And then another thing that I was surprised by is the misconception that society sometimes has about the industry. When I was working in the internship, what I learned is that everyone here is interested in safety, cleanliness, and social responsibilities. We're all looking to be the best stewards of the land and of our communities as possible for our friends, our colleagues, and our families. So to find your internship, the first thing that I would talk about is that an internship is a partnership between you and a potential company that's looking at hiring you possibly as an employee. So a question to ask yourself is, what kind of work environment do you want to work in? Do you want to work long hours? Do you want to have flexible hours? You can ask around. Each company has its own reputation that everyone knows about. And it's about finding a good fit for both sides. You'll notice that each of them have prerequisites. So what do you do if you don't have the skill? I would say right now you're in a great position because you can ask your school to hold a seminar or training class. Or another possibility is that you have the skill and you haven't thought about it yet, because so many of the skills that you learn in university translate into work. So for instance, if you've worked with any databases, one of the things that's difficult to get experience with is software. So I would recommend, if your school doesn't hold a seminar or training class, or if it's a little too late to get into them, contact the company. As a student, you can get a trial version. You can work with the tools. You won't have data, but at least you'll be familiar and comfortable with the software. So Terry kind of went over this before, but where to look and why you should apply for your internship. Terry and I actually spoke 4 years ago at a GSA convention, and we kept in touch. And last year, he asked me a question that, you know, kicked me in the butt. He asked if I was applying for internships, and I tentatively said yes. And his response was, have I worded this strongly enough? You should get an internship, because it is what opens up doors into industry. You can find internships on each of the mining company websites, booths at conventions. Get out of your comfort zone. Talk to people that are there. They're there to talk with you about these opportunities. Your professors are a wealth of information. Not only may they have industry contacts, but at the same time, they've worked with many graduates who are looking for work, so they have the connections. And don't discount your own network. You may know someone who knows a company who is looking for an internship. Reach out to people. So now that you have decided you're applying and you're getting ready for the phone interview, do some research. Know the history of the company, know their values, and pick your 3 strengths. By this, I mean, let's say that you are perseverant and you are adaptable and you're a good team worker. Put that into a star formation. So the situation, the task, the action, and the result. We can use perseverance as an example where, let's say that your professor gave you a project. That's a situation. The task at hand is to answer the question of the project. The action might be, I hit a roadblock in my data. I couldn't find any relationships, so I persevered and found a potential explanation. The result then would be that you presented this to your professor and you took the results and what your professor said and took it in under advisor. Now you've gotten the internship and you're entering the mining industry. Something to be aware of is that there is a lot of jargon, and it's nothing to be worried about. There are people who have worked in the industry 20, 30 years, and they say it without thinking about it. You can just ask. No one will penalize you for asking. But if you want to come in, ahead of the game, what you can do is that you can read books about the history of mining. I actually didn't know about this when I got into the internship, but a geologist here at Newmont Goldcorp gave me Climax, which is the history of Colorado's Climax molybdenum mine. And it goes through the beginnings of the mine process from the first cave blocking experiment all the way to advanced techniques in modern day. If you're going to be going to a specific location, look for a book in that specific location. Before the Gold is written by a geologist who worked for, I believe, 30 years in the Carlin Trend. That would give you a great base and background to start working from. Another thing to keep in mind is the large scope of the industry and on-site mine communities. So as geologists, sometimes it's a surprise realizing that there are so many different people. It takes a community to extract ore, and there are jobs for the community, there are partnerships, and there's production for the world. Making the most of your internship when you have it, the first thing I would say is the 3N rule. You can call it whatever you would like, but it is network, network, network. The more people you talk to and the more connections you have, the more opportunities you'll have, either to shine in your internship or possibly for a full-time position down the road. Of course, work on time, be reliable, and follow your common sense instincts, but also ask questions. This is a learning experience. If you have worked hard and you've learned a lot, you have done your role as an intern. And remember that everyone around you is human. They all have unique experiences that you should ask about. You should learn maybe their path into their current position or why they believe a certain procedure should be followed out the way that they've planned it. And they have problems that you can solve. You're a fresh pair of eyes, and you have, again, overlapping experiences, such as coding, working with large databases, or even seeing geology in your field school. After you have spoken with people, ask for feedback. This shows that you're interested in learning, you're interested in becoming a better geologist, a better employee. And when they give you this feedback, it's always a good idea to say, thank you for blank, blank, blank feedback. reiterating what they've said, and then ask if you can do anything better. This shows that you're willing to learn. And I was taught this a long time ago. I think it really helps to open up questions into how you can become even better. Last but not least is be flexible to change, travel, and extra work experience. All of this is extra experience. And when you do get that interview for a full-time position, you'll have all of these experiences to draw upon, and you won't be a stranger to the industry anymore. So that is my perspective, and we're thankful for your time and looking forward to your questions. I'll pass it back to Talia.
Thanks so much, Elaine. So now we're going to go to questions. I see there are quite a few in the questions box. Please, again, if you are asking a question, if you want to direct it to either Terry or Elaine. Let's start with the first one. So this question is from Remy, and it is for you, Terry. And this person asks, what is the status of need for foreign language skills? Are there languages that are constantly needed? And how about emerging markets driving new language needs?
Hey, excuse me. Hey, Remy, that's an excellent question. And I mean, I look at the South America region, and we operate in a multilingual environment. We have our headquarters, regional headquarters in Miami, and we have operations in Peru and Argentina, as well as advanced projects in Chile and investment in Colombia, which is all Spanish. We also have an operation in Suriname, which is Dutch. We have an advanced exploration project in French Guyana, which is French. We have a project on care and maintenance in Haiti. So you can just see, even in our region, being multilingual is really important. And one of the things, just to show its importance, when the Newmont Goldcorp merger closed just a few months ago, and we were reassessing what does the company look like now and what did it look like before, and English was the dominant language prior to the merger, and with the spin-off out of Nevada Gold, Spanish is now the predominant language of our company. So there's great opportunities to be bilingual, and you look where mineral resources are. I mean, I worked in Eastern Europe and had to learn Bulgarian. I've worked in Southeast Asia on a few occasions. I didn't learn Laos, that's a hard one, but I learned Indonesian. But Russia has a big minerals industry, Eastern Canada, so French is important. I think being bilingual is fast becoming a really strong attribute to most companies, particularly given that it's a global industry.
Thank you, Terry. This next question, I'm going to direct it to Elaine. Maybe you can speak from your experience. It's from Melinda, and she asks, do you have to be almost graduating to do an internship?
The short answer to that is no. Many of the people that I worked with here at Newmont Goldcorp were first, second year undergraduates, but I think it depends on the position that you're going for. For instance, the resource modeling group was looking for someone in a master's program. And also, I could not graduate before I entered this position. That was a prerequisite for this internship.
Okay, thank you. Let's see. So I have another question here, and I'll direct it to Terry. What specific skill sets do you expect from PhDs?
Yeah, this is a good question, and one that comes up often. And unlike the petroleum sector, I think this is something that differentiates the mineral sector, is that PhDs are not a minimum requirement. But where a PhD does come in helpful, particularly used to be sort of almost a prerequisite for advancement to like a VP of exploration role, but what we find it's most advantageous is two things, and that is if it's a specialist field that the PhD is undertaken on, such as I mentioned, geophysics or geochemistry or structural geology, even building on Elaine's comment, there's some that have PhDs in geostatistics used in resource modeling. If it's not a specialized PhD, but it might either be on an economic deposit or it might just be a general geoscience, the skills in the PhD of collating work, developing interpretations, testing, and coming to conclusions are all skill sets that are directly applicable to work that you do as a geoscientist in the industry. So it all depends on what your focus is on your PhD, what you're trying to get out of it, but certainly it's a valuable attribute, but I will say it's not typically a minimum requirement.
Okay, thank you. I have another question here from Tyler, and he asks, what is the volatility of the minerals industry compared to the petroleum industry? Is this minerals sector similar in the volatility? Do you want to take that one, Terry? Yeah.
Yeah, that's a great question. I mean, the short answer is that the resource sector in general is a cyclical industry, be it oil, gas, lead and zinc, gold. What differs between them is the magnitude of the cycles, and it's very difficult because a lot of it's based on, like in the copper business, it's often based on supply and demand, but also so you might, as an industry, provide more than there's demand for and inadvertently create cyclicity. And in demand, if copper's like a harbinger of good times, I don't know if harbinger is the right word, gold is a sign of bad times. So gold usually does well because it's a hedge against inflation or uncertainty in the world, and people go to it for a safe haven. Whereas copper is a commodity when, the world's building things, like they're building more electric cars, they're putting infrastructure in place, and, you're in a positive economic environment. So often driven by those external factors. And one of the things that the industry doesn't do the best job at is how they respond to the cycles. And I purposely made a point of opening up my talk explaining how I'd been impacted by two downturns in what was in the base metal sector in lead and zinc, which tends to have shorter cycles than something like gold, which has longer cycles. And you can be quite exposed, as exploration is sometimes seen as the discretionary expenditure by a company, and you can cut it in bad times. So it's a reality. It's the same sort of reality as the petroleum sector, and the lengths of the cycles are highly variable, as I'm sure the petroleum industry is living through right now and wondering when they're going to come out and get back to $100 a barrel. I don't know if that directly answers you, Tyler, but I'll just close with it's a cyclical sector.
Okay, thanks. Let's see, I'm going to combine a few questions together for you, Elaine. One is, can you talk a bit about the software and computer programs that were the most helpful for you to know as an intern? And then do companies typically offer a program where they help you complete your master's program?
So the software and coding languages, I would say Python is on the rise. It's flexible, easy to learn, and easy to read, so it can be edited. But the software, I would highly recommend looking at both Leapfrog and Vulkan. Leapfrog is coming up. It's a more, I would say, intuitive software, but the heavy lifting is still done by Vulkan, which is a little less intuitive, but like I said, it has features that nothing can compare with. I have not seen anything about helping through a master's program from my position, but I did work with another intern who her entire master's is funded through Newmont Goldcorp. So you just have to keep your eye out. They'll pop up in random places and at random times. And the reason I know she was working through Newmont Goldcorp is because her professor had done so previously. So contact your professors. Thanks for the question.
Thank you.
Talia, just one build. The exploration is another big employer in the sector, and what you find the exploration is they use GIS a lot more, whereas the resource modeling and what Elaine was working with was really 3D stuff. So in the GIS, which can be 3D as well, but is often 2D, ArcGIS and MapInfo are big tools. And just like Elaine said earlier, you can often get student versions, trial versions, and sometimes even trial data sets. And there's, I'm sure YouTube and other places have a wealth of places you can teach yourself if you can't arrange a course or something.
Okay, so looking at the next question, so this question is from Shannon. What would be your advice for people in countries without options for internships? Would the best option for gaining field experience be going with a dissertation project requiring field work? And I guess Terry or Elaine, if either of you or if you both have answers, that would be great.
Yeah, Shannon, I'll start. And I mean, it's a really good question, and it varies very much by country, maturity of the industry. In Australia, it's actually called vacation work, which I think is a really cute way of calling an internship, and that's what I got one of those. Canada and Peru and United States have internship programs, but realizing those that don't, I think good things to do is as you look at if the funding's available. SEG, one of the sponsors here, they often run a lot of field courses to operations, and you can get to see mines up front. And a gentleman who was working for me recently had a good phrase: time spent on reconnaissance is never wasted. And you can watch all the shows you want, but seeing a mine in person and speaking to people in the field. So SEG run courses where you can go on field trips. I was talking with someone recently. Some mapping field courses often coincide those with mine visits, but I think field mapping is another critical skill and a good way to get out in the field. I don't know if, Elaine, you have anything else to add?
Yeah, there was an intern this summer who is from Iran, and the way that she got into the program is that she was completing a PhD. She had completed a master's degree in the U.S. and she came to the U.S. for her PhD again, and that allowed her access to a lot of the field work. She got to go to site. Another thing is that many schools, so I went to Northern Illinois University for my undergraduate, and when we had our field course, we were actively looking for people to maybe fill in positions. So if you look at a couple of the different field camps at universities, you can apply to go with the school, and they have really great classes there.
Okay, let's see. We have another question here. How important is understanding mineral economics in mineral resource investment management?
So, and this was something I was hoping to bring up at some point. One thing I think is really important as you're looking to get into the minerals sector, and I went through a lot of things that the sector likes to see, but keep in mind you don't have to tick all the boxes, and I think Elaine was making a similar point. You don't have to meet all the criteria, so don't ever be scared off about applying for a role if you don't have all the criteria. And when it comes to understanding mineral economics, honestly, it's something that you probably don't see come to. It's good. It's a good basis understanding, because at the end of the day, the economics are what drive everything that's done. I mean, you're not going to use shareholders' money to be defining something that might have no hope of ever being economic. But it's also a skill set that you can learn later in your career. I know when I was, started working for Newmont, they brought in John Sturmell from the Colorado School of Mines to run his week-long mineral economics course. Steve Doggett was brought in to run his mineral economics course for exploration geologists. So if, quite often if your employer thinks it's important for you to have that skill, it's not necessarily an expectation that you'd come into the industry knowing it, but it sure is beneficial if you can.
Okay, thank you. So I know you talked a bit about PhDs, and I have another question here that's been showing up a few times. So this person asks if a PhD graduates are generally considered to be overqualified for graduate programs or graduate positions and should therefore aim for more advanced positions. But just in general, is someone with a PhD overqualified for some positions in this industry?
I mean, I always struggle with this one a little, and it's a really good question, and I'd be asking the same myself in the same shoes. I mean, and it depends on whether you've left the industry, gone back to do a PhD and come back, or you're a fresh graduate. I mean, if you haven't got that industry experience, then you might, sort of be required to start at a graduate level. But one of the things that I think is recognized and understood and might enable you to start, at a level above that, is the investment in those 4 or so years and all the additional skills you bring that are, well above and beyond that from an undergraduate degree. So, I think it really is one of those things that would vary on a case-by-case basis. Shouldn't dissuade you from applying for above entry-level positions, given that you have that extra years of experience that should count for something. And if you were to come in at a graduate level, and that was, that might be the state of the industry at the time or whatnot, I would suspect that you would accelerate probably faster than someone who does not have that additional academic skill set, because you would have more tools in your toolkit on how to present information, how to interpret information, how to work in teams, and other skill sets that someone coming from an undergraduate would not bring to the role.
Yeah, and on that, I would say that I completely agree with Terry that, if you do start at a graduate level, you'll have the chance to accelerate because it'll all be based on the work that's given to you. But also, I did see a lot of an expectation for on-site experience. And so if you have any ability or any way to get that on-site experience, I think that would help you get to a higher level faster.
So I have a question here, a little different than the ones that we've gone through so far. This one comes from Sadie, and the question is, if you're interested in working with policymakers on mining policy, where would be some places to look for experiences and internships?
Yeah, I mean, the answer is really the same, and we have interns at our company, and I'm sure other companies do. At Newmont Goldcorp, it's called the Sustainability and External Relations Group. At other companies, it can be community social relations, and others are environmental social governance. So I find that that policy side has different names depending on the organization, but most companies, it's the same sort of process. In the mining sector, those roles would also be advertised on company websites. For Infomine, the Northern Miner I mentioned earlier is a Canadian publication, but they advertise in very similar spaces because, and I think Elaine touched on this too, it's such an important and big part of what we do as an industry, and it actually follows the exact same mining cycle, whereas you might have engineers just come in to a couple of parts of that cycle in the development and mining phase, whereas social and environmental and people working on mining policy work all the way through that, engaging before you even start exploring. You're engaging with communities, with government, and other such aspects, right the way through to after you close an operation. So I hope that's some helpful guidance, Sadie.
Okay. Kind of a specific question from Stephen. What skills are required of mining geotechnical engineers when seeking entry-level work?
Hey, Stephen. So mining geotechnical work, so there's a couple of fields to that. So sometimes people come in with a geological engineering degree. Some people come in with a civil engineering degree, and others with a pure geological based engineering degree. And the geotech field is also something that I find more than many other disciplines is something that is equally employed by the firms themselves, so companies like the one I work for, as well as consulting and contracting firms. It's something that's quite often outsourced. And what they're looking for is people who understand the geotechnical aspects of rocks, because at the end of the day, that's what it's all about. But I think the number one thing that you'd kind of also want to emphasize is some of those soft understandings of how risk is measured, how risk is applied, safety factors, because at the end of the day, in the geotechnical portion in the mining industry is all about stability of the rocks when you're excavating, and that's underground and open pit. It affects everything from the design factors, which also has impacts on the economics. If you have to have a flatter open pit, you have to mine more waste to get to the ore. If you have to put more ground support underground to keep the rocks in place, such as mesh or bolts or shotcrete or other industry terms creeping in there. So understanding the risk factor, cost trade-offs are often skills that your geoscientists in exploration and whatnot doesn't typically spend as much time focused on. I hope that's helpful.
Thank you, Terry. And so we just have a minute or two left, and I was wondering, Terry or Elaine, if you had any final thoughts for the audience, for undergraduates, graduate students, PhD students, or recent graduates as they move forward in looking into a career in this industry.
I'll let you go first, Elaine.
Thanks. I would say keep your chin up, keep your eyes open, just keep watching the different places for internships and jobs, and persevere. So we haven't really talked too much about it, but the soft skills are just as important as the technical skills. Keeping in touch with your network, being willing to be helpful, those kinds of things. I'm sure that if you've listened to this and you're interested, you're going to do great. Just keep going.
That's awesome. I don't know that I have much more to add to that great overview, but I mean, I will highlight it's not necessarily an easy sector to get into in some places. I kind of talked about it's a much more important sector in Canada, Australia, Peru, Chile, but I agree with, like Elaine was saying, persistence, networking, engaging on LinkedIn, on forums and communities, getting involved in like the Geological Society of Nevada, GSN's meetings, GSA meetings, same with SEG and other that are connected to industry, applying for scholarships, applying for, in the industry, internships and graduate programs. But if you do manage to get into the sector, as you're looking at career paths as a geoscientist, and be that in academia or in government or environmental consulting or oil and gas, I found personally the mineral sector to be incredibly rewarding. We like to think it's it's a small world and even smaller industry. It's been very good to me, and I encourage you to look into it as an opportunity and take the tips we've provided here.
Thank you so much. So this concludes the webinar. Thank you for joining us today. Please contact if you have questions. There will be a short survey that pops up after we close the webinar. We appreciate your feedback, and thank you again to our presenters, Terry and Elaine, and also to our media sponsors, SEG, AGI, AGU, and GSA. So thank you very much and have a great day.